Okay, so the last thing in your notes, we had talked about ocean currents, right? And the warm ocean current is going to warm up areas that normally would be much colder, but they're bringing in warm temperatures, okay? Right here we have rain in an area that has a warmer current versus snow in an area that would have a cooler current. I could speak, okay? Cold water currents and climate is going to do the opposite, right? Cold ocean currents are going to bring cooler temperatures to areas that would be normally warmer, and that creates a cooler temperature in comparison to the inner cities, right? So the cities that are more inland, in this case, may be warmer than the cities that are coastal. Right? Like on the coast of California, you have that California current, right? It is a cold current. Since it is a cold current, it's going to bring cooler temperatures down with it. Okay? Okay. So, the next one is elevation. Elevation we have done before. Okay? Elevation should not be a surprise to you, right? Because the higher up you are, right, you know that it's colder. And how do we know? You can always look on reference table page 14 and look at the trend. Okay? So it has an indirect relationship between air temperature and elevation. So the higher up you go, the cooler your temperatures will be. Right? But this has a direct relationship with precipitation. Right? Because you're forming clouds up higher, which means that you're going to have more precipitation, which is why at the top of mountains, okay, you see snow. And a lot of it, even if it didn't rain down here. You might get some runoff from that snow when it melts to come down here, but that's not necessarily how it's going to work for the rest of it. Okay? So when you're looking at this particular reference table, okay, keep in mind the different landscape regions, okay? You have plateaus, you have Catskill Mountains, you have anything that says plains or lowlands, those are pretty much sea level, okay? If it says mountains, we're talking about higher elevations, okay? So you're going to be responsible for looking at this particular reference table and saying, oh, at the Adirondacks, in the center of where it says Adirondacks, that's going to be much colder than something like the Erie, Ontario lowlands. Okay? They're at pretty much the same latitude, right? But the elevation is different. All right, I told you mountains were different than elevation. Okay? Mountains kind of, when we're looking at them, you want to look at them and say, do they block the wind from the, whatchamacallit? Do they block the wind from the oceans or any sort of water, body of water? Okay? They create what's known as a rain shadow effect. Okay? You have what's known as the windward side and the leeward side of the mountain. Okay? With the rain shadow effect, what it does, and I'm going to show you guys a video clip review of all of these factors that are affecting climate in a few minutes. Okay? All right? So what it does is the cloud is formed, and as the cloud moves over the mountain, it drops all of its precipitation on one side, but on the other side of it, you're going to get more drier air, okay, you're going to put more brownish, more arid of a climate, right? Because you don't have as much water. Whereas on the other side, you're going to see more of a lush green, right? Almost like that rainforest green picture I showed you, right? You're going to see that humid area, right? And it's all because, I'm going to show you a picture in a minute, how the water can get blocked by the mountain from going over it, okay? Like this, okay? Notice that on the left-hand side here, where the sea is located, is going to be our greenery, is going to be our wet side of the mountain, the best way to explain it, okay? On the other side, the side that is further away from the sea, okay, is going to be more arid. You see there's a little cacti down here, right? Because when the sea actually evaporates, it warms up, it evaporates, it moves up, it forms clouds, right? You got that warm, moist air that's rising up, you're forming clouds. Then you drop the precipitation. By the time that it gets to the other side, that dry air is going to fall back down, okay? It's going to fall back down, and you're going to end up with more of an arid climate. So when you're looking at mountains, usually there's going to be what's known as a leeward versus a windward side. Okay? This is just a picture. Thought you guys might like it. See how it's brown? There's not a lot going on here, right? It's more of that arid climate. It's vegetation that is here will be the vegetation that does not require a lot of water. Okay, here's a skyline view of a mountain, and you can see this darker green part that kind of cuts it in half, right? That is the top of the mountain. And you see the side that is closer to the water, right, is more green, more lush, where on the other side, where it's further away from the water, it is more brown. Okay, a little review. We talked about El Nino and La Nina, okay, towards the beginning of the weather chapter, but I'm not sure if you guys remember it, okay. With this, during certain times of the year, this will happen naturally, right? You have those prevailing winds, and you have the currents working usually together, all right? If they're not working together, or if the winds are stronger than the currents, okay, you're going to move the water in one direction or another. What I am going to do for you guys is, again, we're going to watch a video clip so you can see it. We're getting it. Okay, here it is. I think it's this one.
Warmer or colder than average ocean temperatures in one part of the world can influence weather around the globe. Boggles the mind, right? Here's how it works. During normal conditions, trade winds, which blow from east to west, push warm surface waters towards Asia, piling it up in the western Pacific. In some years, though, the trade winds weaken. The warm surface water moves eastward and reduces upwelling of cold water off the coast of South America. Climatologists call this El Nino. Its climate impacts show up mostly in the wintertime over North America. The warmer ocean fuels an intensification and southward shift of the jet stream. This brings flooding to the southern United States and warmer, drier conditions over parts of the Pacific Northwest, northern U.S., and Canada. But eventually, those trade winds pick up again and sometimes become even stronger than normal. When that happens, they blow the warm water back into the western Pacific and restart the upwelling of cool water towards the surface in the eastern Pacific. These strong trade winds are a signature of what is called La Nina. unusually cold conditions in the tropical Pacific that displace the jet stream northward. La Nina can lead to drought in the southern U.S. and cooler temperatures, heavy rains, and flooding in the Pacific Northwest. El Nino and La Nina together are part of a cycle that influences extreme weather and can impact food production, water supply, and even human health, not just in the U.S., but in many parts of the globe.
Okay, so basically, what you just saw is the difference between El Nino and La Nina, right? It has to do with those trade winds. The trade winds will normally move to the west. It's different than the prevailing winds, okay? Those trade winds on a normal day do push warmer ocean climates to the west during certain times of the year. Well, if those trade winds are weaker, the warmer current is going to stay on the western coast of the United States, which ends up leading to warmer temperatures in the water, obviously, which then floods the southern part of the United States, right? Can lead to that because you got more rain, you've got all kinds of fun stuff. Then, when those trade winds do pick up again, they may pick up so much that they push that warm water so far away, allowing the west coast of the United States to be more cold, okay? Which then can lead to droughts because there's not as much water that gets evaporated into the air, which means there's not as much precipitation, okay? That's El Nino and La Nina events. Now, those are natural. That had nothing to do with, in general, like us.
On My Heritage, you can build your family tree and make amazing discoveries about your family history
So excited.
really easily.
So this little video clip is going to be a review of all the climate factors. Remember I said this is one of those topics that is more visual, right? So I found this little video clip. I thought you guys might like it.
Hi guys, this is I'm Stark, and today we are looking at a big factor of our lives, and that is temperature and what factors affect temperature. Now we have 4 factors today which we're going to talk about, and the first one I think is the biggest factor, and that is latitude. So obviously places near to the equator are a lot hotter. So places such as, especially in Africa, are a lot hotter than, for example, the UK, which isn't as near to the equator. Now we've got to know exactly why this is, and that's because this is due to the curvature of the Earth, the angle of the sun in the sky, and the layer of atmosphere that surrounds the Earth. So when the sun is directly overhead, its heat is concentrated upon a small area, which means the land warms up rapidly. Going to the North Poles and the poles, with the North and South Pole, the sun angle in the sky decreases. That's why when the sun is right above of you, it's really, really intense heat. The next one is distance from the sea, and places near to the sea have a small range of temperature. Now this is because in summer the sea heats up slowly and the temperature remains lower. However, in winter the sea remains hotter, so temperatures are fairly mild. So again, that's simply just in summer you might have quite a few colder summers, so I don't know, still hotter than winter, but they're still colder compared to other places. However, in winter, your winter will be fairly mild. Some places in the UK are quite similar to that. However, if we go to some place far from the sea, they have a large range of temperature. And that means in summer they heat up quickly, whilst in winter they lose heat rapidly. So maybe for the countryside or something, in summer they're going to be really, really hot, and it can be unbearable heat, whereas in winter it's going to be very cold because it's losing all that heat very quickly. The next one is prevailing winds. Now, this is because
This is the one you guys want to pay attention to because this is the one that is the hardest to explain without you guys seeing it. So he's going to explain it and show it to you, okay?
the temperature of the wind depends on where it comes from, which is quite self-explanatory. And if the wind blows from the land, it will be warm in summer, but cold in winter. And this isn't what happens in Britain, because in Britain the wind comes from the sea, and that means that it's going to be cooler in summer but warmer in winter. Now that's similar to what I was just saying before about distance from the sea. about how in summer the sea finds it hard to heat up quickly, whereas in winter it cools. It doesn't cool down too quickly. Now the final one is altitude, and this is basically if you've ever been to somewhere like the Pyrenees, for example, and I've got videos on the Pyrenees where I was there, and where everything is very high altitude, it's normally a bit cooler. Now this is because as height increases, the density of the air also increases. Now this means that the air is less able to retain the heat it gets from the ground. This is why snow can stay. So sometimes you might go to a very hot place and snow stays. So thank you very much for watching this video, and see you soon. Bye.
All right, so that pretty much sums up the different factors that affect climate. All right, so do you guys have any questions so far? Okay, so, right, we have climate change. Now, we started talking about climate change a little bit, right? We know that we go through these ice ages, ice ages and interglacial periods naturally. The problem is that humans have affected how fast we go through them, and also how much warmer or colder it has been. Okay, so you've seen this chart or something very similar to this before when I was showing you in general about climate change, right? And I said sometimes we have extreme highs, right, in averages, and extreme lows in averages. Well, we're right now in an extreme high. Okay, now notice the temperatures are only like 29 to 30 degrees Celsius, but if you look at that in Fahrenheit, we're talking about an average of like 70, 80 degrees, okay? And at some point, this high is gonna come down. How far it comes down, we don't know. That's gonna end up going towards an ice age, okay, where it's going to be much cooler. But again, over time, it's going to change, right? This is a glacier. The glaciers, parts of it are melting, and then we get more water in the ocean, okay? What that does is it can actually lead to more flooding, where parts of, this is the one you guys actually saw before, right? The higher temperatures, we have interglacial, and then down at the cooler temperatures, we have more of a glacial effect, right? If you have those glaciers that are melting, okay, you get more water. When you get more water, you can get more flooding, which means that parts of the United States can go under water, right? So what are the causes? Well, we talked about this. The amount of solar output that happens. So how much insolation comes in versus how much goes out, okay? The way the orbit and the axes are, the wobble. This is all stuff, guys, that you've already learned. That's why I'm going through it quickly, right? Volcanism, we did that when I showed you the video of Pompeii, right? It's the volcano that erupted. When the volcano erupted, all of that ejecta went into our atmosphere. When it goes into our atmosphere, it creates almost, or it can create a nuclear winter because it's not allowing the sunlight to come in. Okay? None of this you guys really need to write down because we've already done it. I'm just reviewing it with you. And humans, guys, we just know we're bad. Fossil fuels are bad. They lead to more pollution, which then leads to a warming of the surface of the earth, which then can cause more of a climate change. Right? So that's where we're going to end today. Perfect timing. I will see you guys tomorrow. Good luck. Godspeed. Give me 1 second to just stop recording this.